This is entitled, Let's Invent the Tower-Mounted Communications Pod. Yes, I do have a U.S. patent pending, but let's go back in time and see if we can experience the eureka moment. This is the way we've always done it. We put a building down here to put the radio in, and then close to the building we build a tower. And the tower must be tall because we want the antennas to be able to talk for a great distance. Now we've got the antennas up here, we've got the radio down here, we need to connect them, and coaxial transmission lines is the only real solution. We make the connection and it works. Things are different now. One of the things that is different is we can put a lot more antennas on the tower, sometimes different kinds of antennas. And all these different antennas, of course, need more and more transmission lines, so that over time it begins to resemble some kind of aerial junkyard. At some point, we should ask ourselves, how would we redesign this today with today's technology if we are not constrained by the way that we've always done it? One of the things is the transmission lines. While everything else in radio has gotten to be smaller and a lot cheaper, transmission lines have gotten larger and much more expensive. So, if it costs so much to get the signal from the radio to the antennas, how about if we just moved the building up here, and then we wouldn't have transmission lines? Well, actually, if you do the math, not having transmission lines is a very large cost offset, so let's work on this some more. We may need a wider tower, because an elevator has become necessary. So now we put the antennas up here and we put the building up here. Now all we need to do is just step out of the door to work on the antennas. Well, that's not going to be very popular, so let's put the antennas in the building. Have a bigger building, but then the wind load is too great. But don't give up yet. First off, we can subtract the wind load that would have been on the transmission lines on the tower, which is large. Now, by using aerodynamic streamlining, we soon come to the shape of a flying saucer. All the antennas are around in a big circle, and since antennas can see through most non-metals, the outside windows are now called a radome. And if you do the math now, there is less wind load on the tower than if it had been done the way we've always done it. But the antennas are too tall. We'll talk about that some more later. Once in a while, lightning is a problem. So let's talk about airplanes. If passengers are traveling in an airplane and lightning strikes the airplane, it may be scary, but lightning travels harmlessly around the outer skin of the airplane and discharges someplace else. This is called the skin effect. And if we are careful how we make the communication pod, we can use this same skin effect to protect everything that's inside. By now, we have concepts for different sizes of communication pod. This is a scale model of a partially constructed size that would be used with the monopole. The equipment is installed in modules that are easily removed to the ground. This is simplified by extending the top skin to the leading edge. This way, the top skin serves as an overhanging roof to protect the radome from hail. The radome may now be made thinner, which also reduces attenuation. The actual product will be made of steel that is welded together and then assembled with bolts. The model is made of poster board that is put together with white glue and then is painted. This is Velcro. The hub has eye plates to attach the trusses. The top skin ties it all together, leaving openings underneath for the module. Each module may have everything from the fiber optic and electrical connections to the antennas. That way it can operate autonomously. That way, other modules may remain in service while one or more are being removed. Soon we will have a remotely operated vehicle to remove and replace the modules. The pole will be permanently rigged to a work platform or ROV may be raised. People that work on towers, like me, will fill in for the ROV until it becomes available. It is a little more complicated than that, but I think you get the idea. We should talk about heat. The top skin is stainless steel to limit heat gain from sunlight. Then we sink heat from the circuitry to the large and shaded surface area of the bottom skin by using flat heat pipes. Amazingly, newer technologies use antennas that are shorter and wider. These will more easily fit inside the pod. It also looks like this was made for remote radio heads. If you would like to participate in this conversation about the size of the pod that we should make available, contact me and we'll talk. I am Fred Finley Hine at yahoo.com. Thank you and God bless you.